Most people believe human cooperation evolved so we could hunt mammoths together. The evidence doesn't support that. Before any hominin coordinated a hunt, they had to solve a harder problem: defending carcasses from a predator that outweighed them and could crush their skull in a single bite. The cooperation we take for granted was not an achievement. It was a defense mechanism forced on us by an animal you've probably never heard of. Meet Pachycrocuta. Pachycrocuta brevirostris was the largest bone-cracking carnivore that ever lived. Roughly the mass of a lioness, but built differently: shorter legs, a massively reinforced skull, and premolars engineered to splinter femur bones that no other scavenger could open. Modern spotted hyenas can crack bones. Pachycrocuta could crack the bones of animals 10 times its size. This animal did not hunt large prey. It was a hyper-scavenger. Its entire survival strategy depended on locating carcasses abandoned by saber-toothed cats, Meganterion and Homotherium, and consuming everything, including the skeleton. Here's the critical detail: saber-toothed cats were inefficient eaters. Their iconic teeth prevented them from stripping a carcass clean. They killed large prey, horses, bison, juvenile elephants, consumed roughly a third of the edible tissue, and abandoned the rest. These partially consumed carcasses were a floating caloric jackpot on the early Pleistocene landscape, and Pachycrocuta owned them. A solitary giant hyena arriving at a saber-tooth kill meant the site was now a hyena site. Any other scavenger, including a hominin, either left or became part of the bone scatter. The fossil evidence Fuente Nueva-3. In 2013, a team led by M. Rodríguez published findings from Fuente Nueva-3, a site near Ors in southern Spain, dated to approximately 1.4 million years ago. This is one of the oldest archaeological sites with hominin presence in Western Europe. The site preserved the remains of a Mammuthus meridionalis, a southern mammoth that had been scavenged. On the bones, the researchers found 2 distinct types of marks. One set was hominin cut marks, evidence that early humans had butchered the carcass with stone tools, slicing meat from the bone. The other set was hyena tooth marks, Pachycrocuta tooth marks on the same bones. This was not a sequence where hyenas scavenged what hominins left behind. The marks interleave. The spatial distribution of the bones, the tooth pit morphology, and the cut mark placement all point to the same conclusion: hominins and giant hyenas competed for this carcass at the same time, at the same place. Fuente Nueva-3 is the earliest direct evidence of competition between hominins and Pachycrocuta for a large carcass anywhere in the world. Now here's where it gets interesting: the computer simulation. In September 2023, a team led by Jesus Rodríguez and Ana Mateos at CENIE, Spain's National Research Center for Human Evolution, published a study in Scientific Reports that quantified what Fuente Nueva-3 only implied. They built a computer simulation of the Iberian Peninsula during the Epivillafranchian, roughly 1.2 to 0.8 million years ago. The simulation modeled the entire carnivore guild, saber-toothed cats as the primary predators producing carcasses, Pachycrocuta as the dominant scavenger, and hominins as competing scavengers trying to access the same resource. Then they ran the simulation hundreds of times, varying one variable: the size of the hominin group. The results were stark. When hominins scavenged in groups of fewer than 5 individuals, they could not compete. Giant hyenas outcompeted them every time. Hominins either starved or were forced to abandon the scavenging niche entirely. Below 5, cooperation was not optional. Cooperation was the difference between access and extinction. At 5, something shifted. Groups of 5 could chase off a solitary giant hyena, not comfortably, not every time, but enough to survive. Between 5 and 13 individuals, hominin populations grew. And as hominin populations grew, giant hyena populations declined. The simulation showed an inverse relationship. More cooperating hominins meant fewer successful hyenas. The competition was zero-sum, and the hominins were winning. Above 13, the curve reversed. Groups too large couldn't extract enough calories per individual from a single carcass. The optimum was just over 10, large enough to defend the kill, small enough that everyone got fed. The simulation did not prove that cooperation evolved for carcass defense, but it proved that without it, there was no hominin scavenging at all. Why this changes the origin story. Here's the counterintuitive detail that separates this content from everything else. The standard narrative says, hunting required cooperation, therefore hunting drove cooperation. But hunting big game, the kind that required multiple coordinated individuals, emerged relatively late. The earliest unambiguous evidence of hominins hunting large animals with spears dates to roughly 400,000 years ago at Schöning in Germany. But Pachycrocuta was competing with hominins for carcasses at least 1 million years before that. The pressure to cooperate was already there, harder and earlier, driven not by the ambition to hunt, but by the necessity to defend. This flips the causal arrow. Cooperation did not emerge so we could hunt. Cooperation emerged so we could eat. And the animal that made eating alone impossible for over 1 million years was not a saber-toothed cat. It was a hyena. The saber-toothed cats created the food. Pachycrocuta created the competition. And the competition, the relentless, across generations pressure of arriving at a carcass and facing an animal that could kill you and eat the evidence, selected for the one adaptation that mattered more than any stone tool, the ability to show up with 5, then 10, then 13 others and hold the ground. Rodríguez puts it plainly. Passive scavenging in the presence of a strong competitor, he writes, is essentially the same as confrontational scavenging. You cannot scavenge passively when the alternative to cooperation is losing every carcass to an animal that weighs twice what you do and can crush your bones into powder. The consequence act. Pull all of this together and a picture emerges. Populations that cooperated access the marrow, the fat, the brain tissue of large carcasses, the most calorie-dense resources on the Pleistocene landscape. These nutrients are directly linked to hominin brain expansion. A larger brain requires more energy. You cannot grow a bigger brain on tubers and termites. You need animal fat. Populations that couldn't cooperate, that couldn't field groups of 5 or more, didn't access these resources. They were pushed to the margins. Small prey, plant foraging, seasonal starvation. The fossil record of hominin populations that coexisted with Pachycrocuta but lacked evidence of large carcass butchery tells a story of nutritional constraint. And then there is the extinction. Pachycrocuta brevirostris disappeared from Europe roughly 800,000 years ago. It held on in East Asia until about 500,000 years ago, then vanished entirely. The standard explanation is competition from the spotted hyena, Crocuta, which arrived in Eurasia and occupied the same niche more efficiently. But here is what the timeline shows. By the time Pachycrocuta went extinct, hominins had already solved the problem it created. They were hunting with hafted spears, they were processing carcasses systematically, and they were cooperating at scales that made single scavenger defense irrelevant. The predator that forced cooperation did not go extinct because cooperation stopped being necessary. It went extinct because cooperation had become so effective that the hominins it once starved out had turned into the dominant competitors on every carcass in the ecosystem. What this changes about being human. Here is what changes when you accept the Fuente Nueva-3 evidence and the Rodríguez simulation. Cooperation is not a strategy we invented. It is a strategy that was forced on us by a predator that for over 1 million years made solitary survival a mathematical impossibility. The numbers don't lie. Below 5 individuals, the simulation says, you lose. Above 5, you win. Between 10 and 13, you dominate. The most important technology in human evolution was not a tool, it was the size of the group. And the animal that made group size matter more than any other predator, for longer than any other pressure, was a bone-crushing hyena that never hunted us but spent 2 million years taking everything we needed to survive. We did not learn to share by hunting mammoths together. We learned to share because showing up alone to a carcass was a death sentence, and the only way to eat was to bring enough people that the hyena backed away. The cooperation we take for granted was not an achievement. It was an adaptation to a predator that is no longer here, but left its signature in every structure of human social life. What was the most surprising thing you learned? Drop it below. I read every comment. Subscribe now so you won't miss our next video.